Guys, today I'm going to report about chapter 10 of Management of Network Functions. And my topic is all about memory management. Memory management uses kernel with paging algorithm. It tracks available memory amount. Second, based on goals of local system. And third, global system requires drive local site policies and mechanisms. Memory allocation and reallocation dependencies. Scheduling and resource sharing schemes that optimize networks and resources. Extended role. Memory request has two sources. First is the local source. Local level source is the page allocation based on local policy. Second is the global level sources. Global level sources receives process manager memory requests for new or expanding client or server processes. Second, it uses local resources for memory garbage collection and function. Third, decides most and least active processes. And the fourth one determines the preemptive process to provide space. Third one is the functions of memory management. The functions is to control demand. Control demand allocates and reallocates space requests based on network's usage patterns. Second one is the page fault handling. Page fault handling automatically brings requested page into memory. Third one is to examine total free table before allocating space. Continuations of functions, virtual memory management. Virtual memory management allocates and reallocates virtual memory. Second, it reads and writes to virtual memory. Third one, it swaps virtual pages to disk. And the fourth one, it locks virtual pages in memory and protects pages as needed. So, memory management access allowed has two parts, access allowed and protection. In access allowed, there are 5 types of memory management. First is to read and write. Read and write allows users to have full access to pages, contents, giving them the ability to read and write. Second is the read only. Read only allows users to read the page, but they're not allowed to modify it. Third one is to execute only. Execute only allows users to use the page, but they're not allowed to read or modify it. This means that although a user process can read or write to the page, it can jump to an address within the page and start executing. This is appropriate for shared application software, editors, and compilers. The fourth one is the guard page. Guard page used to facilitate automatic bounce checking on stocks and other types of data structures. The fifth one is the no access. No access prevents users from gaining access to the page. This is typically used by debugging or viruses protection software to prevent a process from reading or writing to a particular page. So guys, I have a sample video for the memory management. Just watch it.
Hello, my name is Sean, and in this tutorial we shall begin with the Memory Manager and look at 3 old schemes of memory management. Single User Contiguous was the first scheme of memory management, and it wasn't very efficient in terms of performance. A single job would reserve the entire memory space. This job would be processed, and then the memory was cleared, allowing the next job to be loaded. If the job size was larger than the space available in the RAM, it could simply not be executed. This scheme is considered impractical for today's modern operating systems, as it would be very slow to process all of the jobs on demand. But what if you wanted to store 2 or 3 jobs in the memory? This is when fixed partitions came along, allowing allocated partitions to contain more than a single job at one time. All of the partitions were stored in a partition memory table to keep track of partition usage. The sizes of these partitions were static, meaning they could not be changed, unless the system was rebooted, so you could see how this would be a problem. A dynamic solution was necessary to avoid having to reboot the computer every time you wanted to process a job. A dynamic partition's available memory is still kept in contiguous blocks, but jobs are only given as much memory as they request when they are loading for the processing. This has proven a significant improvement over fixed partitions because memory is not wasted in the partition. Unfortunately, this is not a complete solution. Both fixed and dynamic partitions need some way to allocate jobs to the available partitions. There are two ways to do this. The first fit quite simply finds the first partition that has sufficient storage space, not taking into account how much memory could be wasted in the allocated partition. The best fit first looks for the smallest partition, resulting in more space for other jobs, resulting in slower performance but better efficiency. So, when a job has completed processing, it is then removed from memory, also known as deallocation. With a fixed partition, this is fine, it is simply cleared. But when using a dynamic partition, it gets more complex to free up memory as it tries to join together adjacent blocks. So, looking at these simple allocation schemes, we can see there are still problems. Each one required the memory manager to store the entire program in the main memory at contiguous locations. We need to find a way to avoid having to keep the whole program in memory to run, and the restriction of storing the programs contiguously. What if we could divide the jobs into separate, smaller chunks? We can. Virtual memory is the solution, and we shall look at the evolution of 4 memory allocation schemes. Let us start with paged memory allocation, allowing us to divide the job into equal-sized parts. The sections of a disk are known as sectors or blocks, and the sections of main memory are known as page frames. Before executing a program, the memory manager makes some preparations. First, it determines how many pages are in the program, and then it locates enough empty page frames in the main memory so that it can pass all the pages into them. The adjacent memory blocks do not have to be loaded in as adjacent memory blocks. They can be stored in any available page frame in the main memory. Now, this is a more efficient scheme, but it does come with complications. We need a way to keep track of all the page locations, which increases complexity in the operation. Through the use of 3 tables stored in the part of the main memory, we can keep an eye on locations of various jobs. The job table is a dynamic list that contains 2 values, the size of the job and the page map table location of that job. The page map table contains important information for each of the pages, the page number, and its corresponding page frame memory address. Finally, the memory map table has 1 entry for each page frame, listing both its location and a status informing whether it is in a busy or free state. Now that we have an understanding of paged map allocation, we can now see how demand paging works. It's very similar to the previous concept, but the main difference is that pages are loaded on demand, meaning that pages are only brought into memory when they are actually needed. The page map table we looked at before increases with 3 more columns. 1 to determine if the page is already in memory, known as the status. The second to check if the page has been modified. And a third to check if the page has been referenced recently. How do we determine replacement of pages? By using a page replacement policy. First in, first out. Least recently used, least frequently used, and most recently used are replacement policies used to change pages based on a specific algorithm. These are all pretty self-explanatory and are crucial to the efficiency of the system. So we have looked at page map allocation and demand paging. But what else is there? Well, we have looked at separating the jobs into pages. What if we could break it down even further? We can. Segmented memory allocation splits the job into separate segments that reflect the nature and structure of the code. Usually, when you view a script, it is separated into individual functions or subroutines that can be called one at a time. You may have a function called add that makes a calculation of two numbers, and a function called divide. We can call these one after the other, and they will run in the chosen order. Now, take all of these functions and label them as segments. Instead of using a page map table, we now have a segment map table that makes a list of all of the varied sized segments that need to be put in the main memory to process. Now we move on to the final scheme. It is a mixture of segmented and demand paging memory allocation. It offers the logical benefits of the segmentation idea as well as the physical benefits of paging. There is no new logic involved, but there are some minor modifications to point out. It makes use of both the segment map table and page map table, plus additional information of authority to read, write, and execute a file. A major disadvantage of this is the overheads and complexity of adding in more tables to handle the load. Why is virtual memory a good thing? Well, let's say we currently have RAM that is fully occupied and has no time for jobs waiting to be slotted into it. Because we use segmentation and paging, we can exceed memory capacity by turning to the backup memory, the hard drive. And although it's a slower alternative, it can act as an extension to the RAM. We have come a long way in memory, but at an increased processing cost, the operating system can provide a more efficient service to allow the CPU, the central processing unit, to handle jobs with better time frames and effectiveness. This has been Sean, and in the next episode, we will move on to the Process Manager. Please do not forget to subscribe to the SMKS channel.
Hi everyone, for the continuation for the memory management, my topic is all about process management. So first, I will define what is process management. So process management is an integral part of any modern day of an operating system. The OS must allocate resources to process, enable processes to share and exchange information, protect the resources of each process from other processes, and enable synchronization among processes. So they undergo processes in order to synchronize all the data resources that the device may gather. So sa process management, it provides policies and mechanisms. So first, there are different policies and mechanisms of this process management, such as create, delete, abort, name, rename, find, schedule, block, run, synchronize processes, and it provides real-time priority execution if required. So it manages execution states, ready, running, and wait. So in process management, there are manages execution. So in process management, it manages execution states such as ready, running, and wait. And then in process management, we have here the kernel. So kernel is a computer program that is the core of a computer's operating system with complete control over everything in the system. And most systems, it is one of the first programs located on startup. And also kernel handles the rest of starting up as well as the input or output requests from software. So the kernel role is it helps systems reach operations goals. And then it states that dependent on global systems processes or process scheduler and dispatcher. So in system scheduling function, there are three parts, which are the decision mode, priority function, and arbitration rule. So if I'm going to define each, decision mode is determines policies when scheduling resource, and there are options preemptive, non-preemptive, and round robin. So in priority function, scheduling a algorithm policy assigning order given to process in execution cycle. So examples, most time, remaining, and LTR, and so on. So arbitration rule, it resolves the conflicts between equal priority jobs. So example is last in or katong first out, first in, first out. And then sa process management, there are job scheduling advances. The theories are queuing theory, statistical decision theory, and estimation theory. So the process functions are the specific procedures, create process, and the locate process. So in specific procedures, na siya yung katong rule niya, which is to create, locate, synchronize, and delete process. Muna siya sa specific na procedures. While sa create processes, PCB with additional information, identifying network location. So gina-define niya and locating niya ang network location. And then sa locate process, uses system directory or process researching kernel queuing spaces. And then it requires inter-processes communication support. So sa process management, there are synchronized processes. So it uses message, repassing, or remote procedure calls. So sa synchronized processes, delete or termination process finds PCB, access it, and deletes it. So there are do's and don'ts decide, which is the process based do's, do or don'ts, and object based do's and don'ts. And then process-based do's and don'ts, process management using client or server processes is synchronized and linked together through messages and ports or channels or pipes. So it emphasizes also the processes and messages. It's providing basic features essential to process and management. So process management has a single OS copy and multiple cooperating peers and also combination of two. And then the high-level cooperation and sharing, actions and data. And also synchronization is key issue in network processes management. It interrupts represented as messages and sent to a proper process for service. And then the second one is the object-based do's and don'ts. This one are systems viewed as collection of objects, and the examples of these are hardware, CPUs, memory, and the software are files and programs, and or the combination between them. And then the objects viewed as abstract entities, and objects have a set of unchanging properties. And also, process management becomes object management. Processes act as a discrete objects, and there are two process management components, such as the kernel level and the process management. So sa kernel level, ano siya nag-provides of basic mechanisms for building OS. And ang iyang responsibilities is maintains network capabilities and responsible for process synchronization and communication support. So sa communication between distributed objects, nag-share siya data with objects and messages objects, and dinakontrol niya ang interaction. And then, the process manager creates own primitives. So if kernel does not have primitives, example the test and set and p and V. So, the responsibilities niya is to creating, dispatching, scheduling objects, and synchronizing object operations. And also, object communication and deleting objects. Muna siya responsibilities for the process manager. And then, the kernel environment to perform above tasks. So, siya ang kernel nag-perform sa mga tasks for the process. And also, objects contain all their states information. And so, that's all. And to further explain my report, I have my sample video for you guys. Bye-bye!
Hello, my name is Sean, and in this tutorial, we shall move on to the Process Manager and look at how the processor and its manager work to process the jobs being passed through to memory. It is important to understand that processors vary in performance, speed, and bandwidth, so results vary from machine to machine. But there are some factors to appreciate. The clock speed refers to the speed at which the processor can execute instructions. So, the quicker the clock speed, the more cycles are run, and essentially, the more instructions are carried out. Do not always be fooled, though. The efficiency of the processor's architecture determines how much work the processor actually does. The bandwidth determines how much information can be processed in one instruction. The wider the bandwidth, the more that can be fitted on and sent. Think of it as a motorway. The wider the road, the more cars, or in this case, instructions, can be run at the same time. The processor has its own version of memory, also known as cache, that exists on the die of a processor. Because it has less time to travel, it is usually checked first before calling in a page from the RAM. Cache can be accessed between 5 to 10 times faster than accessing the RAM. A process scheduler is in charge of making efficient use of the physical processor. There are two parts to this. One is the job scheduler, and the other is the process scheduler, taking note that a job can consist of many processes. It can juggle many jobs. A process can be in 5 different states: hold, ready, run, wait, and finish. Hold is controlled by the job scheduler, and as the name suggests, it is holding the job until it has permission to run. Think of a car race. You cannot start the engine until the starting signal has been called. Now, when your engine is on, you are in a ready state. The ready state is a signal to continue with the process. When the car is ready to proceed, it is in a running state. In our case, it is currently processing the job. Throughout this time of running, there may be a concern of performance, so a check with the team is made to ensure it is okay to start running again, returning to a ready state. If it is okay to run again, it goes back into a running state. But what if there is an engine failure? In that case, an I/O request page fault is presented, and the car is put in a waiting state until it has found the correct resource or part so that it can continue to run. This will loop constantly until the process has either completed or failed, where it is then put into a finishing state. Each process has a life cycle. The process control block is used as an identifier and contains basic information about the job. What is it doing? Where is it going? How much processing has it currently done? And most importantly, how much it has spent in using resources. With the use of a process control block, we can place those in the correct queues. Think of the queue as a linked list of PCBs. This has been Sean. Please do not forget to subscribe to the SMKS channel.
In
continuation with the process management and operating system, my topic is about the device management. So first, we will define what is a device management. So a device management is a control panel applied in Microsoft Windows operating system. So it allows users to view and control the hardware attached to the computer. So example, the flash drive. When you attach it to the device, computer example, the user can view the file inside the flash drive. And next, it opened, read from, written to, and closed. So when a piece of hardware is not working, the offending hardware is highlighted for the user to view it. And then, we also have the process-based, the do's and don'ts. So the resources controlled by servers are called guardians or administrators. So their responsibilities are of a device management. It accepts and requests for service in individual devices they control. It processes each request fairly, and it provides service to requestor, and lastly, it returns to serve others. So system administrator and users can learn how to perform such tasks as running commands, handling processes, handling files, and directories, backing up and restoring the system, managing physical and logical storage, and basic printing. So as we all know that the device is something that is in hardware or something that is attached to the device hardware. Object-based do's and don'ts. So each device managed the same way throughout the network. Physical device considered an object. So for example, the laptop, we call it a device, but it is also an object because it is a hardware. So physical device considered an object is surrounded by software layer. So physical device manipulated by a set of operators. Operations mobilizing device to perform executed functions, and objects assembled to communicate and synchronize. Local device manager cannot satisfy user request sent to another device manager. So if a local device manager dili siya satisfy sa request sa user, the local device request sent to another device manager. So it requests to another device manager. So object assembled to communicate and synchronize. If local device manager cannot satisfy user, as I said a while ago, request sent to another device manager. And users, they do not need to know if centralized or distributed network resources. So device manager object at each site contains current directory of device objects at all sites. So that is all about device management. Thank you. To further explain my report, I have a sample video about my topic, the device management.
Hello, my name is Sean, and in this tutorial we shall look into the device manager. There is a constant change in the marketplace with device technology. The device manager must manage every peripheral device. It has 4 basic functions. 1. It has to monitor the status of each device. 2. Enforce policies to determine which process will get a device and how long for. 3. Allocation. And 4. Deallocation, something we discussed previously. There are 3 types of devices to take into account. A dedicated device processes one job at a time. These are devices like printers, tapes, and floppy disks. A shared device can be assigned to multiple processes, like direct access storage, and these processes can be shared at the same time by interweaving requests. Finally, there are virtual devices that are a combination of the two, shared through a mechanism such as a spooler. A spooler is controlled by a program, putting jobs in a queue and taking them on one at a time. A printer queue would be an example of this. A good spooler should let you cancel or change the order of documents. Direct access storage are devices that read and write to a specific place, and we shall discuss the three main categories that are very well known. The size of a large CD, a fixed head magnetic disk storage, is covered with magnetic film. It is then formatted into concentric circles, and each of these circles is known as a track, and data is recorded onto each track by a fixed read and write head that is positioned over it. Movable head magnetic disks, such as a hard disk, have one read-write head that floats over each surface of each disk. They can be single platter or part of a disk pack, and because the head and arm can move, tracks can be smaller, resulting in more space to store data. It is common to be using a hard disk, as they have reduced in price, but they are constrained to the speed of the moving head. 7200 or 5400 RPM are the common speeds.
Hi guys, my topic is all about file management. So first, what is file management? File management simply means organizing and keeping track of files and folders. It helps you stay organized so information is easy to locate and use. Using the file management tools, you can save files in folders with appropriate names, so these files can be found or identified easily. It creates new folders quickly for recognition of information, delete unnecessary files and folders, search for files and folders, create shortcut of files for quick access and compressed files. So, provide transparent mechanism. 9-7 mechanism file management in operating system. First is find and open. It uses a master directory with information about all files stored anywhere on the system and sets up a channel to the file. Second, read. It sets up a channel to the file and attempts to read it using simple file access schemes. However, a read operation won't work if the file is currently being created or modified. Third, write. It sets up a channel to the file and attempts to write to it using simple file access schemes. To write a file, the requesting process must have exclusive access to it. This can be accomplished by locking the file, a technique frequently used in database systems. When a file is locked, all other requesting processes must wait until the file is unlocked before they can write or read the file. Fourth is to close. It sends a command to the remote server to unlock that file. This is typically accomplished by changing the information in the directory in the file storage site. Then fifth, read. It creates a unique file identifier in the network's master's directory and assigns space for it on a storage device. And last is to delete. It erases the unique file identifier in the master directory and deallocate the space reserved to it on a storage device. So there are 6 tasks in file management in operating system. First is concurrency control. It is a system ability to perform concurrent reads and writes, and it provides actions do not jeopardize database, and also it provides serial execution views on database. Second, data redundancy. It makes files faster and easier to read. It allows process to read, copy, closest or easier to access, and read requests split into several different requests for larger files. So now, advantage or disadvantage of data redundancy. Advantage data redundancy is disaster recovery easy, while disadvantage of data redundancy is keeping multiple copies of same file up to date at all times and updates performed at all sites. So third is location transparency and distributed directory. It means the user not concerned with physical location of files because it deals with network as a single system. It provides by mechanism and directories, which map logical data items to physical locations. Fourth is location transparency and distributed directory. Distributed data allocation transparency, and enhances data recovery for users. Distributed directory contains definition for stored physical data and logical structure, policies and mechanism mapping the two, and system-wide names of all resources and addressing mechanism for locating and accessing them. The fifth is deadlock resolution or recovery. So it is the critical issues in distributed system. So now ito ka important function or recovery or deadlock resolution. First is to detect and recover from a circular way. Second is the complex and difficult to detect because it involves multiple processes and multiple resources. And so now four strategies used by distributed system: detection, prevention, avoidance, recovery. The first is recognize circular weights. The system uses the record resource graphs and it looks for cycle. Second is prevent circular weight. It delays transaction start until it has all resources. Third is avoid circular weight. It allows execution if transaction can run to completion. And lastly, the recovery. System selects best victims, kills victims, reallocate its resources to the waiting processes. The last file management task is query processing. It is the function of processing requests for information and it increases effectiveness. So now three sequences query processing. First is global query execution sequences. Second is local site processing sequences. Third is device processing sequences. And query processing, it also ensures consistency of entire system's scheduling scheme. The query processing strategy and integral processing scheduling strategy part. That's it. Further explain my topic in file management in operating system, I have here a sample video for you guys. Further
Hello, my name is Sean, and in this tutorial, we shall briefly look into the File Manager. The File Manager has a complex job and is in charge of the physical components, its information resources, and the policies used to store and distribute files. It has to perform 4 tasks. It has to keep track of where each file is stored, use a policy to determine how the file should be stored, allocate each file when a user has been cleared for access, and deallocate the file when it is returned to storage. Think of the File Manager as a library, and a librarian has to use a catalogue to keep track of all of the items in the collection. This is all arranged based on a policy that stores all types of items, books, DVDs, maps, etc., and can be found with ease no matter what the type is. When the item is requested, it is retrieved by the borrower, and the name is noted down for reference. When the borrower has finished using the item, it is given back to the librarian so that he or she can make note of it before putting it back. Now we have a basic understanding of the main managers of an operating system, and we can visualize how managers can start to work together. So, when you are using your computer, tablet, and mobile, take the time to appreciate all of the hard work the physical components, operating system, and software are doing when you are making use of it. If you would like to learn more, a suggestion would be to buy some of the books listed in this description. Once again, this has been Sean, and this concludes the series of tutorials on operating systems. Do not forget to subscribe to the SMKS channel, or visit the website at www.smks.co.uk. A donation in order to create more tutorials would be greatly appreciated.
So, hi guys, it's me again. So, today I'm going to report again about network management. Network management provides concurrent process policies. intra-site and intra-site communication. So its responsibilities are to locate, process in network, send messages through network, track media use, reliably transfer data, code and decode messages, and retransmit errors. Perform parity checking, do cyclic redundancy checks, establish redundant links. And the last one is to acknowledge message and replies if necessary. So links processes objects together through port when communication is needed. Provides routing functions, keep network use statics like messages scheduling, fault localizations, and rerouting. Aids process time synchronization, system-wide clock. Process-based boost. Inter-process communication transparent to users. So its responsibilities are allocating ports to processes, identifying every processing network, controlling message flow, and guaranteeing transmission and acceptance of messages without errors. So the third one is interfacing mechanism for every process. Traffic operator accepts, interprets, send, and receive commands. So it has 4 functions. First one is send. Send allows objects to send a message with operations to any object in the system. Second is to receive. Receive warns objects of incoming communications from an object in the system. Third one is to request. Request provides mechanism for objects to ask for a particular service. For example, they can request that a message can be sent. Reply. Reply allows objects to do one of 3 things. First is to respond to requests for communication from another object. Second is to respond to a send command that they aren't prepared for. Third one is to indicate that they're ready to accept a send message command. A message can now be sent knowing that the receiver is awaiting it. So, NOS development. NOS runs on server. Performs on network services workstation. NOS runs on server. Performs network services workstations called clients. Network management functions. Only when system needs to use network. Third one is to focus on sharing resources, not running programs. Factors for best NOS choice is applications to run on server, technical support required, users training level. Important NOS features. First one is to support. Support standard local area network technologies. Client desktop operating system. Second one is the robust architecture adapting easily to new technologies. Support every operating system in corporate information network. Third one is to operate wide range of third-party software applications and hardware devices. Fourth one is to support multi-user network applications, software, and the fifth one is to blend efficiency with security. Major NOS functions. Transfer files between computers. Example, FTP command. Not through a file sharing. You must copy file to local disk, duplicates and waste space. Needs version control. Anonymous FTP. Files available to general public. And its advantage when for FTP, users know how to use browser. That's all we do.
Let us look at how to draw a network diagram for a hospital project. In the interest of better serving the public in India, Dr. Vikas Gupta has decided to build a hospital in a small village which is currently lacking good medical facilities. With the help of his staff, Dr. Gupta has identified 11 major project activities. He has also specified the immediate predecessors, which is the activities that must be completed before a particular activity can begin. For each activity, as shown in the table. So activity A is to select administrative and medical staff. Now this activity is not dependent on any other activity to be finished before this can start. Activity B is to select a site and do the site survey. Again, this is also not dependent on any other activity and can be done independently. Activity C is to select the equipment. So basically he has to select the equipment for the hospital. Now this is dependent on activity A to be completed before he can start C. So he should select the administrative and medical staff first and then select the equipment. Activity D is to prepare the final construction plans and layout. This is dependent on activity B to be finished before activity D can start. So activity B is select site and do site survey. So once he does the selection of the site and the site survey, then he can prepare the final construction plans and layout. Activity E is to bring utilities to the site. This is also dependent on activity B, which is select site and do site survey. Activity F is interview applicants and fill positions in nursing, support staff, maintenance, and security. Now this is dependent on activity A, which is to select administrative and medical staff. Activity G, which is purchase and take delivery of equipment, is dependent on activity C, which is to select the equipment. So only after he has selected the equipment will he make a purchase and take the delivery of the equipment. Activity H is to construct the hospital. This is dependent on activity D, which is to prepare the final construction plans and layout. Activity I is develop an information system. This is also dependent on activity A, which is select administrative and medical staff. Activity J is to install the equipment. Now this is dependent on three activities, which is E, G, and H. So in order to install the equipment, first he has to finish activity E, which is bring utilities to the site, activity G, which is purchase and take delivery of equipment, and activity H, which is construct the hospital. Activity K is to train nurses and support staff. Now this is dependent on activities F, I, and J, which are interview applicants and fill positions in nursing, support staff, maintenance, and security, develop an information system, and install the equipment. So these are the various activities that Dr. Vikas Gupta has identified in order to construct or build a new hospital. So let's try to draw the AON network diagram, which is activity on nodes, and AOA diagram, which is activity on arrows or activity on arc diagram. So I have listed the activities and the immediate predecessors here so that we can quickly refer to this while we are drawing the network diagram. So first let's look at the AON, which is activity on node diagram. Now in this example, A and B do not have any predecessors. So they are not dependent on any other activities to finish before they can be started. So first we can start with activities A and B. Now in this example, I'll be using blue ink to represent activities. So this is the start box. Now here we can draw two arrows. Now we can draw the activities A and B. So this is A and this is B. So in this activity list we have completed A and B. Now let's find out which are the activities which are dependent on A. So we have C, we have F, and we have I. So all these three activities, which is C, F and I, have to start once A has been completed. So let's draw this. So 3 arrows from A, and then we'll draw the activities I, F and C. So this is I, this is F, and this is C. Here we have completed C, F and I. Now let's find out which are the activities which are dependent on the completion of activity B. So we have D, E, and that's it. So D and E are dependent on the completion of B. So let's draw D and E. So from B we'll draw 2 arrows. This is 1 and this is 2. And now let's draw the activities D and E. So let's say this is D and this is E. So we have also completed D and E. Now next activity is G, which is dependent on C. So let's draw this. So from C we'll draw an arrow, and this will be our activity G. So we have completed activity G. Next is activity H, which is dependent on D. So from D we'll draw an arrow and then draw the activity H. So we have also completed H here. Next is J, which is dependent on E, G and H. So J is dependent on E, G and H. So let's draw 3 arrows. So from G, H and E, the next activity is J. Now we'll draw the activity. This is J. So we have also completed J. Next is K, which is dependent on F, I and J. So F, I and J. So let's draw this. So an arrow from I, an arrow from F and an arrow from J. And then let's draw the activity, which is K. Now as you would note, K is not a predecessor for any other activities, so K will follow to the finish point. So this is finish. So this is the AON representation where the activities are presented on the nodes, and arrows indicate the sequence in which they are to be performed. Now let us look at an activity on ARC network diagram for these activities. Now in this method, the activities are represented by arrows. So we'll represent the activities in the blue color. So as given in the list of activities, A and B do not have any predecessors. So A and B will emerge from the start box. So let's draw this. So from start we'll draw two arrows representing activities A and activity B. Now let us draw the events at the end of these activities. So here we have completed activity A and activity B. Now let's see which activities are dependent on activity A. So we have C, F and I. So let's draw C, F and I. So we'll draw three arrows representing C, F and I. Let's say this is F, this is I, and this is C. So we have completed C, F and I. Now let's identify the activities which are dependent on activity B, which is D and E. So let's draw the arrows representing activities D and E. So from this node we'll draw two arrows, one representing E and the other representing D. So we have completed D and E. Now the next one is G, which is dependent on C, and there are no other activities which are dependent on C. So let's draw G. So first we'll draw a node at the end of C, and then let's draw G. So we have completed G. Next is H, which is dependent on D, and there is no other activity which is dependent on D. So let's draw H. So first we'll draw the node at the end of D, and then let's draw the activity H. So we have completed H also. Now the next is J, which is dependent on E, G and H. So J is dependent on E, G and H. So let's draw J. So J can start after G, H and I are completed. So let's draw the node of completion, and then let's draw the activity J. So here we have completed the activity J. Now next one is K, which is dependent on F, I and J. So F, I and J. Now here we have a complexity. If we draw the node for completion here for K to start, F and I will have the same starting node and the same ending node, which is not acceptable as per the rules of drawing the AOA network diagram. But at the same time, K is dependent on the completion of I and F. So what do we do in this case? So what we can do is we can draw a node here and point a dummy activity from I to K. So let's try doing that. So we'll draw a dummy node here, and we'll draw another node here, and we'll point a dummy activity here. So what this would mean is that the activity K is dependent on the completion of F, I and J, and also at the same time F and I are not starting from the same node and ending at the same node. So K will be like this, and since K is not a predecessor for any of the activities, K will end up in the finish box. Now in the activity on arc network diagram, another task that we need to do is to number the nodes. So let's try doing that. So let's say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8, and this is 9. So generally this numbering has to start from the left hand side and move to the right hand side. Now based on both the network diagrams that we saw, the AON and AOA, you would note that both these approaches can accurately represent all the activities and precedence relationships in a project. The AOA approach, that is the activity on arc, often requires fewer nodes than the AON approach. So the one that we had done previously, that is the AON approach, needed 13 nodes, whereas the AOA diagram that we have done now needed only 9 nodes. In contrast, the AON approach, that is the activity on node approach, doesn't need dummy activities, whereas the AOA approach needs dummy activities. Any of these two approaches can be used in modeling a large project as a network, as this forces the managers to identify the necessary activities and recognize the precedence relationships. If this part of pre-planning is skipped, generally the project would experience unexpected delays.